What I'd like to discuss with you now is what is responsible for the phases of the moon. As you can see in this image, most people think that the phases of the moon are a result of shadows. Well, now, based on what you're seeing here, you can see that it has nothing to do with shadows. What the phases of the moon is caused by, it's caused by the movement of the moon around the Earth, changing the amount of surface reflected based on the Earth, Sun, and Moon relationship. Okay, now this is a little misrepresented here, because what you're seeing is that it's actually going around, and I don't want you to think that this happens over the course of a day. This actually takes 30 days to complete from phase to phase. Okay, and that's where we actually get the term month from. It's actually derived from the word moon. Okay, so what you're looking at here is, by changing the position of the moon in its orbit around Earth, what we do is we see a different portion of the lit section of the moon. Now, if you're looking from space, it always looks like it's half lit. It's 50% lit, 50% dark when you're looking from space. But if you're actually looking from the Earth's surface, what you're going to do is you're going to notice that we're going to see a different portion of the illuminated moon. So as you can see down here, a new moon, as depicted up here, let me go ahead and get my thing working here. New pen. Okay, as you can see up here, this up here is the new moon. What's happening here is sunlight is actually, the sunlit portion of the moon is not even facing Earth. So this is what we end up seeing. We end up seeing, no illuminated side, and that's called a new moon. Well, as the moon continues to orbit around here, what you're going to notice is you're going to notice that we start to see this sliver. That's our waxing crescent. Now, with this, then you progress the moon on through its orbit, and as it progresses through, what you're doing is you're changing the amount of sunlit surface observed from Earth because of this. So what you can see is this is the progression of the phases of the moon. And for this, it actually takes about 30 days. So in all actuality, you have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 phases. So you're looking at anywhere from each phase being 3 to 4 days. Okay? So that's what's responsible. Nothing dealing with shadows there. All right, another term that you're going to see is waxing and waning. Of course, what I want you to be able to do, and one of the hardest things to do, is to determine is it waxing or is it waning. Whenever you see the term waxing, that's actually talking about it's gaining in illumination. So in other words, you're going to be gaining in actual illuminated side. So really we're progressing this direction. This right here is our waxing crescent. This right here is our first quarter, and this is our waxing gibbous. And of course then whenever you have full illumination, that is your full moon, and then you're going to see that it's going to progress this way. Now this is the correct order, okay? Unlike it's observed over here. But what you see is you see a waning gibbous, a third quarter, and then a waning crescent. So whenever you look up into the night sky and you're trying to determine if it's waxing or waning, all you have to do is say if it's the right side that is illuminated, that is going to be your waxing. And if it's the left side, then it's basically waning. Okay. One thing that you're going to notice is every time you look up into the night sky, this is the side that we actually see. We never get to see this side. Only astronauts have got to see what is called the far side of the moon. So the question is why do we only see this one side? Okay, well, what this diagram is actually showing you is the moon has what is called a geosynchronous revolution and rotation. So it's geosynchronized, meaning that basically one rotation on its axis is 30 days. Oops, sorry, let's go back here. 30 days. Well, if you were to actually look at this 30 days, what ends up happening here is now it's revolution. How long does it take to make one complete orbit? Well, that's also 30 days. Where a lot of people get mixed up is they think that it has something to do with it's matched up with the Earth's rotation and revolution. It is not. It has the same rotation and revolutionary periods. So if you're looking at, like, let's use a term day and year on the moon, 1 day on the moon is actually 30 days, and 1 year on the moon is 30 days. Okay, so it has a geosynchronous revolution and rotation. Okay, what you're looking at here is basically you can see that the diameters of the moon are slightly different, and this of course is going to, this is a question. Well, whenever you start to see the moon at a smaller diameter, it's going to be as what is called apogee. Whereas if you look at the moon whenever it's larger, that's at perigee. And what it really has to do with is apogee, because of this elliptical orbit that we have, it is actually farther away from Earth. So the moon appears smaller. So the reason the moon appears smaller is because of the distance factor. Okay? Supermoon, whenever you start talking about supermoons, this has been we've had a lot of these recently. What you're going to notice is a supermoon is whenever we have a full moon. It's in a full moon phase, and it's at perigee. That's when it's at its closest. Okay, this one gets a little bit tricky here, because here's what's going to happen. I'm going to flip back here and kind of look at, I'll use this diagram right here. All right, let's just cross this aspect out. This is the moon we're going to focus on over here. So here's what you have to remember. You have to remember that the Earth rotates 15 degrees per hour. Okay? So every hour we're moving around, and of course we're rotating counterclockwise. Well, tonight you go out and see the moon, and let's say that you see the moon right there. Okay? So you're perfectly lined up. Well, here's what you have to do is every night that moon, so right here would have been its rise time, which we're going to cover because that's a big deal. That right there is actually 6 p.m. So in other words, the sun is over here. Sunlight is coming this way. That's a full moon phase. So we'll just cover in that backside. So from Earth, it's seen as a full moon. Okay, so we see it rise at 6 p.m. Tomorrow night, I'm like, wow, that's cool. I want to go out tomorrow night and see it again. So I go out there at 6 p.m. and the next thing you know, it's like, whoa, it's not here. Okay? Well, at 6:52, I then see the moon rise along the horizon. And the reason that I see the moon rise 52 minutes later, instead of 6 p.m., it's now at 6:52, is because 360 degrees is what this thing revolves. Well, if you look at 360 degrees, 30 days to do that, the moon actually moves 12 degrees per day. Okay? So with that, what's ending up happening is tonight you see the moon right there rise, and then tomorrow night you're going to see it right there rise. That's because the moon will have moved 12 degrees in its orbit around the Earth. And of course, if we go 15 degrees per hour, but the moon only moves 12, that 12 degrees equals 52 minutes. Okay? So that's what you're looking at there. That's what explains the 52 minutes change every single day. All right. The last thing that I want to cover here on dealing with the phases of the moon is the rise and set times. This is one that everybody seems to have a lot of trouble with, and they kind of, I'll just make it nice and simple here for you. How do you determine the rise and set times? Well, that's going to, of course, depend upon which phase it is. So we're going to start looking at these things individually. The first thing you have to do is you have to take and make your actual Earth a clock, as is done here. Okay? Of course, sunlight is coming from this direction, and of course, as indicated, we rotate counterclockwise. Okay, so let's just start with a new moon. So this is number 1 over here. This is where we're going to start. So we're not going to worry about any of these other phases. Here's the thing. If you are right here, okay, you're right there at this time, you are not going to see that full moon, or excuse me, that new moon, because it's on the other side of the Earth. Well, you're going to keep on going around, and bam, right there. Right there, you're going to see the moon along the eastern horizon. Now, that is, of course, if you could see a new moon, but notice it is not illuminated. Well, We're just looking at this. So the rise time for this moon is 6 a.m. Well, as you keep on going, there's where the new moon would be at its meridian. That's its highest point in the sky. So that's noon. And then that moon would actually set at 6 p.m. So whenever you start looking at this, if we could actually see a new moon, the rise time would be 6 a.m. The set time would be 6 p.m. Okay? So now let's go ahead and look at, let's just make this simple. Let's look at the first quarter. So now we're going to go to the first quarter moon. Let me do some erasing here so we can get this cleaned up. Okay, here we go. Let's get some erasing going on. Now we're going to highlight. Okay, let's say that it is 6 a.m. and you're in the morning and you're saying, oh, wow, it's going to be a first quarter moon tonight. I want to see if I can see it. Well, here's the thing. You're not going to see it right there. You're not going to see it at 9 a.m. At noon, you can actually start to see the first quarter right along the horizon. So it'll be to the eastern horizon. Well, of course, when is it going to be at its meridian? Its highest point is going to be 6 p.m. And then the first quarter will set at midnight. Okay? So as you can see, every time I've done one of these, what it is it's really nothing but a game of angles. So if you're looking at this waning gibbous, right? Boom. Boom. You notice that you're always in 12-hour increments. Because we go counterclockwise, the rise time for this one would be 9 p.m. and the set time would be 9 a.m. Okay? You're looking at a waxing crescent. Let me clean this up a little bit again. So let's go over here. Boy, my screen is touchy tonight. Okay. What you're going to see here is you're going to see that for a waning crescent, the rise time would be 3 a.m. The set time would be 3 p.m. So hopefully that actually clears everything up on how you actually determine the rise and set times of each one of these. Of course, every night is going to be 52 minutes later, but you're not ever going to go completely full circle because the revolution of the Earth around the sun is going to balance things out. Okay? So that's what you're looking at with the phases of the moon. Hopefully you have a really good understanding. The next lecture I'll be making is over lunar and solar eclipses.